I think I am live now. Can anyone confirm if audio and everything is fine before we get started? I am planning to discuss all the problems of CodeChef Starter 131 because I was able to solve all of them. And like, how was your contest? Hello everyone. Okay, K-Closeness doesn't make sense to me after reading. Don't worry, we will go through it one. Yeah, probably I will start from due to problems and we can quickly complete those and then I will move to the one problem. So like let's start with remaining neighbors first. Remaining members says an elected election as elections approach across the country of Saffron, the SAF's campaign is in full swing. SAF city has exactly 100 neighborhoods. SAF has already visited n of them to canvass for vote, and he won't stop until he visited every last one of them. How many more neighbors does SAF needs to visit? We are given an integer n, and we have to say print the difference of n and 100. So, like if SAF has already visited 78 people, if he visit 22 more, the total number of visited neighbor would be 100. So like that gives us the 20. If Chef has visited all of them, he no longer need to visit any new neighbor. And like the solution is to take n as input and print 100 minus n. Okay. And I think pretty much this was the idea for remaining neighbors. Like if there are other questions related to like how to improve or anything, I will take them up at the end when I'm done with discussing all the problems. Going to catch them all. You are playing your favorite video game, Pokemon. The objective of game is of course to catch them all. There are n different Pokemons in the game. The ith of them has catching difficulty of AI. To catch these Pokemons, you must use Pokeballs. There are two types of Pokeball available to you. Normal Pokeball, which costs X coins. You need to throw exactly AI normal Pokeballs to catch Pokemon whose catching difficulty is AI. Master Pokeball, which costs Y coins. You need to throw only one Master Pokeball to catch any Pokemon, no matter what its difficulty is. Find the minimum number of coins you need to spend on buying Pokeballs so that you can catch all the N Pokemon. So if we look at this problem, it says we have two types of power. First, which takes X cost, and if AI is the power, we need to throw X balls to to catch it. And the cost of it, like we need to throw AI balls, and each ball costs X. So like overall, like the minimum the cost if we go by throwing only the first type of Pokeball would be X into AI. We also have a second type of ball which costs Y, which is known as Master Pokeball. And like if we throw this ball, one ball, we will be able to catch the Pokemon. And like if you see, Like it doesn't make sense to like first throw, like let's say like if power is 50, it does not make sense to throw 10 pokeballs of first type and then one pokeball of the second type, because like this is the redundant cost we would be paying. So we have either two choice. Either we throw all the X balls of first type by paying cost X into AI, or we only throw the type of ball second type paying cost Y. So to, and like we can take minimum of both of these to find the cost for catching a particular Pokemon, which would be minimum of X into AI comma Y. And like we can take this as sum of all the Pokemons we have, and like that would be our final answer here. So like first I took n, x and y as input, count like the final cost I need, and then I took all the numbers as input, and like power into x if I go with the first type, or y minimum of both of these should be the cost I need. If I take sum of all of them, like the final count would be the cost I have to pay for this Pokemon. And I think this was pretty much the answer for this problem. I will move to third problem as well. And like once we are done with it, like if there are any questions on the first three problems, we can do it. Alice and Bobs are playing a board game. On their turn, a player must roll n standard six-sided die, and their action will be determined by the sum of values on the top faces of the die. On the certain turn of Alice, she rolls the dice, obtains the sequence A1 to AN on the top faces. However, Bob isn't paying attention, allowing Alice to cheat at it. Alice can choose a die and flip it so the opposite face is upward. Note that these are standard six-sided die. So the sum of values on the opposite faces is 7. That is 1 is opposite to 6, 2 is opposite to 5, 3 is opposite to 4. So like if you see, if you have a 4 and if you turn it, you will get 3. So there is no point in reducing the sum because we want the maximum sum. While if 2 is at the top, then if we change it to 5, then like we can increase our sum by 3. So if 1 is at the top, we can increase sum by 5. If 2 is at the top, we can increase sum by 3. If 1 is at the top, we can increase sum by 4. But if 4 is at the top, there is no need to change it. If 5 is at the top, there is no need to change it. And if 6 is at the top, there is no need to change it. So what we can do is like we can greedily find 1 and then change it to 6. We can keep doing it. Once once there are no longer ones, we can then start flipping 2, and then we can start flipping 3. And like once we are done with cape flips, we should stop doing the flips. And like essentially this is the idea I had. All numbers as input. Like let's just sort all the numbers. If flip count is less than k, I can increase the number of flips and sum plus equal to 7 minus x, else sum plus equal to x, and at last I can print the sum. Like this was my idea for this problem. Any questions on the first three problem before we move to the next problems? Any questions on these three problems before we move to the D1 problem? Okay, no questions. Then let's move to the D1 problem. First one is K-Closeness. It says you are given an array A of length n and an integer k. You can perform the following operation. Choose an index I and increase AI by k. Find the minimum possible value of AI, max of a minus min of a attainable, and if you can perform this operation as many times as you like, possibly 0 times. The first line of input contains t, and like a and j, everything is given to us. So like let's see like what does the problem statement is asking us to do. Problem statement says we are given a fixed integer k, and then we are given some integer. Let's take one of the example as input. Okay, like examples are no longer helpful here. Like let's pick some random example. Let's say k is equal to 4, and like ai value we have is 2, 10, 13, and let's say 5. The first thing you notice that whenever you increase any number by k, either the max remains same or the max increases. So the idea would be like, first let's keep doing the operation as long as max does not change, because that can potentially increase the value of min of a, because whenever you change something, either min of a increases or it remains same. So let's keep doing the plus k operations on the number as long as the max does not changes, so that this difference is as small as possible. The idea here would be like, we can change this 5 to 9, 9 to 13. We can also change this 2 to 6, 6 to 10, and 10 plus 4 gives us 14. So like nothing over there. Like once we are done with this, like this would give us one possible difference, which is 3 in this case. Then the next idea would be like, let's just increase the maximum number once. No, sorry, let's increase the minimum number once. So max decreases as small, the increase in max is as small as possible. So for example, smallest number here is 14. We increase it once, like now we can see like the difference would be 1 here. And like now one thing we can do more is like, we can again take the minimum and we can increase, keep doing this and so on. So the idea, like greedy idea here is, or even better, the greedy idea is, you first increase all numbers such that max does not changes. The reasoning for doing this is like, max is not changing here and we increase minimum to as large as possible, so that max minus min remains the same. Once we are done with this algorithm, we look at the current max and min difference, and then we find minimum, add plus k to it, and we keep doing it once. Like you notice like when, like once this is done, like the difference in all the numbers is would be less than k, because like if it's more than k, then if you increase something, like the max numbers should increase here. Like once you are done with this algorithm, once this step is complete, like, because let's say like you have max as 14 and some numbers 7 is there. If the difference is less than k, greater than equal to k, like then you can always change this number to +1 to decrease the difference again. And the idea is like, we will try, we can keep doing this part again, and like we find minimum number at plus k to it, and you will notice that now this number becomes the maximum. And like you will also notice like, if we keep finding max and keep adding it, like after n times, all numbers will be touched once in step 2. So the critical part was like once you are done with step 1, like you have to do step 2 only n times, and then the same cycle will keep repeating it. And like that was my idea for this problem. Like there are other ideas to make everything mod k, and like that will also work. And that was in fact actually what I did in the contest. So there are 2 steps. First, like keep increasing all the numbers by plus k such that your maximum does not changes, and like there can be a lot of operations in the first step. And the second step is find minimum, add plus k to it, do it. And if you like, and whenever you do this thing, the number which you have increased right now will become the new maximum. So, and like the critical observation was if you do second step n times, then you will increase all the numbers at max once, and then the smallest number will again repeat again. So like for example, let's take some better example. 1, 6, 20, 15. Let's say this is our number and k is 4. Choose any number, add plus 5 to it as long as it's less than maximum. Looks fine. Choose any number, increase it as long as it's less than maximum. Choose any number, keep increasing it. Now you notice like if you increase any number, your like minimum would increase, would maximum would be more than 20. Now find the minimum number, add plus 1 to it. Find the minimum number, add plus 1 to it. Find the minimum number, add plus 4 to it. Find the minimum number, add plus 4 to it. Now you see like this would be the again the maximum, and like you notice like 17, 18, 20, 15 were the initial numbers, and now you have 21, 22, 24, 23. Like the same process will keep repeating it, and all the numbers will increase by plus 1. And the idea is like take difference between max and min at each point of time, and we would be good here. And like pretty much that was the idea I had. Like I will code it once, but before I start coding, like any questions on the idea, like why this should hopefully work, at least not a regress proof I don't have, but yeah. Or like does this greedy idea makes any sense? Like one problem here would be like you will have to be a bit smart. You will have to be a bit smart on the step 1. Like you cannot keep doing it iteratively. Like when should we stop it? Like the first idea is like we can use one for loop to do the step 1, and the second idea is we should do step 2 n number of times and then stop. Because here if you notice numbers of 17, 18, 20 and 19, after plus 4 to all of them, like the same number, like same pattern starts repeating here. Like step 1, like a lot of operations can be there, so you will have to be a bit fast, because let's say k is 1, max is 10 to the power 9 and min is 1, so you might have to add 10 to the power 9 minus 1 times for that part. So like step 1, like you can use some division algorithm to first find like how many times the numbers needs to be there, and like that would be the idea. Like what is the problem code? K-Close. Like let's just sort all the numbers. Now first we should like this is the difference between max and the original number, and if we divide by k, like that can be the number of times we can increase without crossing K over here. So like this is step 1. And then we can put all of these numbers in a set. Like let's just sort all of them again. Like we can in fact put two numbers in set or priority queue, whatever you want. Like first value can be the min value, and the second one should be the largest value. We need step 2 only on time. First I find the min index. I erase it. Min index plus equal to k. And then put it again. New min index. Like first element would be the minimum one and the last element would be the maximum one. And like this should be the code for this problem. Like the critical idea here is like this new max index would in fact be equal to old min index. So that's the reason why after n operations, like it will keep repeating it, because earlier the difference of all the numbers is less than k. And like this was my idea for this problem. Any questions on this one or anything before we move to the next problem? Yeah, like the mod approach was like, the one thing is like the critical part was when you do plus k, then the value of k, like if s plus k, then the value of mod sk remains always same. So like what few people did was like, instead of this step 1, they replaced all the numbers ai with ai mod k. And this is essentially the same, like you have basically subtracted max by k seal into k here. And like that was the other idea few people had. So like both of them are equivalent, but yeah, like yes. And like the other critical observation is like once you sort the numbers, like in fact you don't really need this set here. Like let's say this I. If we increase I plus, right now I is the minimum, I index would be the minimum. If we increase it by k, I becomes the largest number. And like so like we can in fact do this thing as well. Like this will also work. Like the main reason why this works is like we have sorted all the numbers here. Yes, like sorting the array and moving it like kind of two pointer, not exactly two pointer, but yeah, that was the idea for this problem. And yeah, like these were some different things you can play around with this in this problem. And I think I pretty much discussed all the optimizations I had for this problem. Yes, like Christian, that's the idea. Initial answer is max minus min, then pop left and append the pop plus k and keep checking min plus. Yeah. So like any more questions on this one before we move to the next problem? Yes, I did solve all the problems, and I would say like for CodeChef starters, generally like last problem becomes bottleneck for me, and generally I am able to solve if it's rated until 5 star. Like for D1, like there are a lot of problems that remains unsolved for me. Okay, next problem says encrypt value. You are given an array A containing n integers. Consider the following process. Let s equal to 0 initially. For each I from 1 to n in order, update s to either s plus ai or s into ai. That is either add ai to s or multiply by ai. Before performing the operations, you are allowed to freely rearrange the elements of a as you like. If you choose the rearrangement of a and sequence of operations optimally, what is the maximum possible value of s that you can obtain? This maximum value can be very large, so print it modulo these numbers. So like the problem statement says, the problem statement says we have some numbers a1, a2 up to an. We also have a number s. First, we can rearrange these numbers however we want, which is initialized. Now we iterate on all the numbers, and we have two choices. Either we can do s plus equal to a or s equal to s into a. And at last, we want x as large as possible. And the other idea is like because s would be very large number, printed mod something. The critical part is we should maximize x, not the maximum of s percent whatever mod is given to us. Like we should find the original value of maximum and then we should print it mod. Not that we should print the maximum possible value we can get after taking mod. So this was the first part. And like one critical observation was like, let's look at like either AI is 1 or AI is greater than 1. Like first thing I did was like that sort all numbers in increasing order. Like the main idea which I am looking for is like I did got a penalty for it as well. Like x plus, if you have two numbers x comma y, then x plus y will always be less than equal to x into y. If like let's say x comma y are both greater than equal to 2, then x plus y will always be less than equal to x into y. Because the idea is, let's say like there are two cases here. If x is less than equal to y, then x plus y is less than equal to 2 into times y. Because x is less than equal to y, this would be less than y into y. This would be less than equal to 2 into y. And because like I have also assumed like all the numbers are greater than equal to 2, this would in fact be equal to x get x into y. Like if both the numbers are greater than equal to 2, then their sum will always be less than equal to their product. Like once we know this, like whenever like one of the number is not 1, it never really makes sense to add them. Rather, if we multiply them, then we would get a better product all the time. So like problems are AI equal to 1. If there was no AI equal to 1, then we would have just multiplied all the numbers and printed the product with the given one. And like once we notice this critical fact, like we can first count, like we can first remove all the ones. And we know that if we don't make no difference in one, like in the first operation, like let's say the numbers are b1, b2, b3, b4. In the first step, we can do plus operation to get b1. Then we can multiply by b1 to get b1 into b2. Then we multiply by b3 to get b1 into b3. Like this can be the sequence of operation plus, multiply, multiply, multiply. And if everything is greater than 1, then this is the maximum product we can get. Like that was my critical idea. Now my idea was like because we have ones, so multiplying by 1 makes no sense. The number does not changes. So for 1 we should always do plus 1. And like once I had this, like my idea was like let's look at the numbers as b1, b2, b3 up to bk whatever we have. And like we also, let's say we also know the count of 1. My idea was to choose one number and add count 1 to it. Like basically the process would look like earlier I will keep adding all the ones to get count 1. Then I will take the smallest number. I will either multiply it by b2. Like basically I think the greedy in fact should work here. Like sort all the numbers in the increasing order. If current number is 0, or if the current number is 1, then you should add, otherwise you should multiply. And like that should work, I think. Let me first try it once. Like let's just put all the numbers here. If current number is 0, now the number is no longer 0 and res plus equal to x. Continue. If x is 1, then we should do res plus plus and continue. Otherwise, the current number is otherwise x is greater than 2 and res can be 0, res can be 1 or like greater than 1. So the idea here would be if like when we do operation for the first time, so if current number is 1, we do res plus equal to current number and res plus equal to mod. Otherwise, we should also always multiply by current number and print it. I think this should be the core algorithm that should work. Okay, like there are some critical cases, I believe. If current number is 0, then we should always add it. If current number is 1 and the res is 1, like then is 1 is true. Yes, that's the idea. The idea is if current number is sort all numbers and like this is the rearranged way. Like if s is less than 2 or current number is less than 2, like basically if s is 0 or s is 1 or like the current number is 1, then do s plus equal to current number or do s multiply into current number. The main problem is like after some operations, like the number can be 1 in 9 plus 8. In this case, mod value would be 1. So like you should be critical that whenever like the number is 1 in 9 plus 8 or something like that, such that the mod is 1, then like you should multiply instead of add. And like that was the solution I had. Like Rishabh says, like I was thinking if s is 1 in 9 plus 6, I shouldn't add 1 since mod will make it 0. And I was stuck around these cases. Were my concern totally wrong? Yes. Like the idea is like when your number 1 in 9 plus 6 plus 1 will make it 1 in 9 plus 7 and the value mod would be 0. So like what you can see is like the product is in fact 1 in 9 plus 7 here. Although like the value you are printing is 0. And you should maximize this value and whatever product you get should be your final answer. Like print maximum value, like find maximum value, and then print it mod, given mod. Like this is what the problem statement is asking us to do. Problem statement is not asking us to say print maximum value you can get after taking mod at each step. Like this is not what problem statement is asking us to do. Rather, problem statement is find maximum value of s and then take it mod and print it. Instead of like what is the maximum value with a given mod you can get. And like that was like that I also tried to clarify earlier as well. And like that was the idea I had. Any questions on this one? Like the main critical observation was if both the numbers are greater than 2, then like x plus y would be less than equal to x multiplied by y. So like now we can sort all the numbers in the increasing order so that all the ones are used first, and then you start using 2, 3, 4, whatever you want to get the maximum possible product you can get. And in fact, you can say that the greedy idea also works. Like just take maximum possible value of x plus y comma x into y at each step, and then take it mod. Just that the problem would be like since you have to print final value as mod, so like you would have to be a bit critical to handle those cases here. So like this was the idea I had for encrypt value. Any questions on this one before we move to the next problem? The idea was like I explicitly maintain is the value 0, is the value 1, so that next time when I visit them, like that I don't need it. Why not use DP? Like you can in fact use DP. Like the only problem may be because of like you have to maintain a very big integer here, and like that might not be feasible. Like you can in fact maintain like DP after sort all the numbers. Then you can say like DPI is max of like this is in fact what we are doing. Just that the only critical observation was once we sort the numbers, like and like once we start multiply, once we do at like once AI and DPI both becomes greater than 2, like this sum is no longer really required here. Like you can write kind of this, but the only thing you will have to do is like mod should be taken at last, and because you cannot take mod in the states in between, then like you will have to maintain like very large integers here, and like that might not be feasible here. Like there can be some workarounds to deal with it, but yeah, you cannot write the numbers like this. Like this is the W here. Mod should be taken at last. So like that was my idea for this problem. Any questions on this one before we move to the next problem? Okay, moving to the next problem, T-Perm. It says Chef is sick solving problems related to binary representation of integer. So he decides to change things up. Obviously, 3 is larger than 2, so ternary must be better than binary. Chef thinks an integer is good if its ternary, that is base 3 representation, contains digit 2. For example, 5, 6, and 14 are good. Their ternary representations are 1, 2 for 5, 2, 0 for 6, 1, 1, 2 for 14, respectively, while 1, 2 is not, being 1, 1, 0 in ternary. You are given an integer n. Find any permutation p of integers 1 to n such that for each I from 1 to n, pi plus I is good. It can be shown that for the given constant, at least one such permutation always exists. Input format this and like output just contains an integer. Like this was the critical part. Like there is at least one such permutation exists. Like one thing you can notice that like the problem statement itself says like find a permutation of all the numbers. Like first it defines a number as good if ternary representation contains 2, and then it says find a permutation such that for each index I plus pi is good. Like let's first look at the simplified definition of ternary representation here. Like instead of looking at any digit, let's look at only the last digit. Like my idea was like first let's define pi equal to I here, so that the numbers would be 2, 4, 6. Like I can say what I did. Let's just choose the identity permutation at first. Then we can also define I plus pi. This would be 2, 4, 6, 8, 10, 12, 14, 16, and so on. And like let's look at the last digit. Like this is good, this is not good, and like 6 can be good, or like let's look at I plus pi mod 3 here. This value would be 2. Like the last digit is 2 in ternary. Last digit in ternary here is 1. Last digit in ternary here is 0. Last digit in ternary here is 2. Like basically the last digit is taken value mod 3. The last digit here is 1. The last digit here is 0. And the last digit here would be again 2, and so on. Like critically what you see is like if you take mod over everything, the numbers becomes 1, 2, 4, and so on. But like if you now swap these two numbers, like 3 here and 2 here, both of these numbers will become 5, and last digit is 2 now. So like that was the next thing I did when I noticed like if the numbers are, if I only look at the last digit will always be 0, 1, and 2, and it will always repeat in sequence 0, 1, 2, 0, like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, sorry, 0, 1, 2, 0, 1, 2, 0, 1, 2. So like if I do 1 plus 1, it would be 2. If I do 0 plus 2, it would be 2. Like first thing. Last digit will all, because in ternary all the digits are 0, 1, 2. 1 plus 1 is 2. 0 plus 2 is also 2. So like I can initially pair numbers such that like when the last digit is 0, I pair it with the other number where the last digit is 2. And if the last digit is 0, I can pair it with other number whenever the last digit is 2 and so on. So like here the last digit is 1, I am good. Here the last digit is 2. So I pair it with the number with the last digit as 0. So like 2, 3, 2, 3, sum is 5. 4 plus 4 is 8, fine. For 5, 6. Right now none of them works. But if I make it 6, 5, this sum becomes 11 and the last digit is 2 here internally. And I can keep doing it. The problem happens when, let's say, like in this, if you try keep doing it like this, it can happen that the only last number is not paired. Like for example, if last number is, let's say, if n is 22, then their sum is 44, the last digit is 2, we are good here. But if let's say n is 23, then we do not have 24 to pair it up, because our so we need some other pair for 23. Like to reach it, my idea was like there are a lot of digits. Instead of looking at any digit as 2, I will only look at the last digit and try to form as many pairs as I can. And when I inspected the last digit, what I saw was 0 plus 2 is 2, 1 plus 1 is 2. So I can start by pairing the numbers such that I pair last digit. Whenever last digit of I is 0, I make pi as last digit of pi as 2. And whenever like last digit of I is 2, I make pi as 0 and like so on the idea. So the idea was like 1, 1, 3, 2, 4, 6, 5, 7, 9, 8 and so on. And if I keep pairing, keep making the pairs, it can happen that the last digit, like I would always be able to form. I will fix all numbers correctly except maybe like n where I have made pn equal to n. Like that was my first step of the idea over here. And then I did something more for the last step. If I initially fill all the numbers as one. If like one based indexing. So like if the last digit is already 2, I don't have to do anything. Otherwise, I know that if I swap with the next number, then I should be good. Otherwise, it's the swap case. So I swap and then I have some assert to check it. And then I skip one more number here. And the idea was like this process should fail only when so in that case, like I can start with all the numbers and I can keep swapping the numbers here. So the idea is like once I am done with the initial assignment, like for like I probably need some number for I. So like what I can do is I can start with j equal to 1 to n minus 1 and try to swap some aj with ai so that both the numbers are good. And whenever I find any such index, I break over there and I close whatever loop I had. And like I also have a definition of check which checks if any digit is 3 in the ternary. Like the first idea was if current number slash digit is 2, I am good. Otherwise, if like the idea is like after 2, like if you look at the parts here, I am always swapping it with the next pair. So if I have a next pair, I swap it with the next pair, and I have some assert to ensure that the value is same. And I then also say like ignore like the current value. And like if there is no next pair, then like this if will fail only for I equal to n. Now I can run a for loop for all the numbers before it, and I can try to find one pair such that like numbers remains good after I am swapping it. So like if I assign like AI in the place of J and J at the place of I, if it's good, I swap them. I fall as false and break here, and like that was the higher. How are you sure there will always exist some element which can be swapped with the last number? To be honest, I was not sure. But like what I knew was like there would be a lot of permutations over here, and like this should definitely work. And like pretty much like this assertions in statement ensure that if any of my assumptions fail, like it should break. And like that was the code I have written. Like I can probably try to prove it over here, but in the contest I did not prove it, to be honest. And like the leap of faith I had was like if I look at the last digit, the probability of last digit being 2 is 1 by 3. Or in fact, like if you pick any random digit, like probability of it would be like if you take numbers from 1 to n, random number from 1 to n, then like if you write it in ternary, then probability of like let's say probability of bi being 2 is 1 by 3, probability of b2 by 3 is 1 by 3, and so on. So like the only way to ensure like this algorithm works is probably to run for the all the small numbers and see if it's working or not. Or like and like that was what I tried to do in the contest. And to be honest, I'm not really sure over here. But what I knew was like this should hopefully work. It did not give me a WA, and then I went ahead with it. T-Perm, like what was the editorial? Like first it's working with modulo 3. This works fine. This is the case. Okay, like it's like if you look at the editorial, it's saying like you will like it's explicitly hard coding some pair. Like there are some cases to prove it, but yeah, like there are some other cases as well, but I did not bother dealing with it. Like you can probably read the editorial to find out like why this algorithm should work. And like that's what essentially I did in the contest. Like any more questions on this one before we move to the next problem? Like I would be back in a minute or two, and like if there are more questions, I can take them up, or otherwise I will move to the next problem. either I am back. Like in fact, like the very first submission I made on this problem was to just randomly shuffle and keep printing, unless you have found the permutation. But unfortunately, it got a TLE. Like the first meme submission I had was to just randomly shuffle, check if it's good. If it's good, print it. Otherwise, keep trying to find the new permutation. And unfortunately, it did not work because probably a lot of collisions. But yeah, like digit space for an integer x, I define it digit space dx to be set of all positive integers whose decimal representation is rearranged to the of the decimal representation of x when written without leading zeros. So, for example, if you have 2024, then the possible numbers in the digit space are 4022, 4202, and so on. But 0224 is not allowed because you cannot have 0 beforehand. For two integer x and y, define x and y be the maximum prime number that divides both x and y. So now you are given some x and y, and like f of x and y is defined as the maximum possible prime number which divides both of them. If no prime divides both the numbers, we said like the number is 1 instead. For example, 35 and 105, 7 divides both of them, and this is the largest number. Although 35 divides both of them, but 35 is not a prime number here. So that's why f of this is 7. F of 2, 3 is 1. Now we are given two integers x and y, and we have to compute the maximum possible value of f of ab, where a belongs to digit space of x and b belongs to digit space of y. That is, compute maximum possible common prime factor of two numbers such that one is rearrangement of x and other is rearrangement of y. So that is the problem statement. The way we can do it is like we can first look at each x independently, find all the numbers in the digit space of x, and find all prime factors for each number in digit space. Similarly, we can try to find like all the possible numbers in digit space of y, and then all the prime numbers in digit space of y, and then we can look at both of these sets and take the maximum common number in this set. Like that should work, right? So let's say I have some function which takes a number x and returns all the prime divisors of all the possible numbers in digit space we have. So I can run it to get all the possible prime factors that can be possible in digit space of x. I can run it again to get all the possible prime factors in digit space of y. Then I can find the largest common number in them. The idea is iterate on all the numbers in one of the sets, and if it exists in the other set, assign it to y, and we are good. Like this would be some brute force algorithm. The question is like, how can I find all the prime factors? Like first question is, how can I find all the numbers in digit space? One thing you can notice is like the number is less than 10 to the power 7. So there are x has 6 digits. So we can in fact find all the permutations. Like there cannot be more than 6 factorial numbers because there are only 6 digits. So we can try to find all the 6 factorial numbers, and then we can factorize each of them. And put it in the set of prime numbers we have. And for factorization, the optimization I did was pre-compute all primes. Like generally for loop we do for prime factorization is for I equal to 2, I into I is less than n, I plus plus. If n divides I, put that number and everything whatever you want. Like for prime factorization, I pre-computed all the possible prime factors which were less than 10 to the power. First, like it's the Steve algorithm to find all the prime factorization less than 1e4 IF. Now I can take the given number x to the string, sort all the digits, And then I can use built-in next permutation function to fetch all the permutations of all the digits of x. If first digit 0 is not allowed, so I skip it. Otherwise, I convert current number using STOL method to a number x, current. And then I check on all the prime factorizations. If 2 times prime is greater than current, break it. Otherwise, keep dividing it with the current prime and insert this into the set you have. And at last, you can also insert the current number. Current will either be 1 or current will be equal to the largest possible prime factor of the number initially you have. And like this was the, like at the end of this, like your set will contain all the possible prime factors you can get. And then you can use it to print it. And like that was the idea here. Like I am checking, like, do we really need all the prime factorization to run? So like there are few pieces of the problem here, like you might want to read about it. Next permutation function, like how to generate all the permutations you have given a digit here, how to factorize a number. And I think like here, like you can probably like, and like I also use sieve to calculate all possible primes. Yeah, like you will have to in fact calculate all the numbers, and like this iteration should only be done on the prime factorization, not all the possible numbers. Any questions on this one before we move to the next problem? Okay, I will move to the next problem then. ABC conjecture 2. Like this one was a bit tricky one. Like let's read the problem statement. For a string s containing only characters A, B, C, we define f of s as follows. Consider the following operation. Consider any subsequence of s that equals ABC. Delete either A or B from it. Note that it reduces the length of s by 1. Formally choose any index I, J, and K such that Si equal to 1, Sj equal to B, and Sk equal to C. Delete either index I or J from S. F of S is defined to be minimum number of moves you can make such that it's impossible to perform any further moves on the resulting string. For example, f of s a b c is 1, f of this is 0, whatever you want. You are given string s of length, and for each character s is either a, b, or c. Let s L2R denote the substring from L, substring of s from index L to index R, that is string this. Find like this sum for f of value for all the substrings here. Like there are few critical observations here. Like notice that we only delete character A and B, like C always remains the same. And let's try to find the value of f of A comma B for the original. Let's find first f of s. And like let's see how can we find it. Then we will try to do it for all the substrings there. The idea is like there would be some string which will consist of A, B, then some C, then some string, then some C. One thing you can notice, like you can never delete C. And like let's say like the last character is C here. Then anything after it, like order does not matter. After the last time when C occurs, order, like we will not be able to delete the characters after the last C. Because if you pick any character from here, like either A or B, you will need a C there. So we can ignore all the characters after the last C. Like other way to look at it is, if the last character is not equal to C, you don't have to do anything over here, and the value of function will remain same if you remove that character from there. And now in some simplified version, we have some string S, which are some characters, and then there is a character C here. Now notice that if there is A here and then there is B here, then you would be able to apply one operation here. So whenever, like after A, like there should be always A's here. Like basically the optimal string will look more like, then you have some C. Like C's can be inserted anywhere here. Then you will have some last C, and then there would be some numbers in any way, like A, B, B, A, and like this is how like the string looks like, where you cannot make any operations here. Like any questions on this one? Like initially the string will consist of B, E, and C, some part of the string. Then there would be some part of the string which will consist only of A and C. And then there would be some string which will consist of only A and B. And like that's, and the in the string of like this, like you will never be able to find whatever we want here. First some string of B and C, then some string of A and C, and then a string of A and B. In the string like this, like you will never be able to find A and B. Because if you pick B from like you will, if you pick A from here, then, and if like you cannot, then the next B would be in this part and there is no C after it. Or if you pick A from here, you would be able to pick some B, but there is no C after it. So like this is how the optimal string looks like. Any questions on this one before we try to solve it as a subproblem? Like once we know this, like we can first solve the brute force subtask. Like the problem is, as long as the last character is not C, we simply ignore it. Now if T is empty, then there was no C here, and like we don't really need some operations here. And like now we should like basically like once we fix a string in such a way, like now we have some string where there are some C's in between and the last character is C as well. Then let's see like what we can do. Like we can choose some index mid. Such that before mid only B and C are there and after mid only A and C are there. And we can use the prefix function on B or prefix function on A to count the number of A's in a particular sequence. So like you should delete all the possible A's in this part. So like the number of A's you need to delete is pref mid. And you should delete all the B's in this part. Like let's say like this is M. Pref B here. And like that should be the number of operations you need to delete. And like you can iterate on all the possible mid to get all the possible values. Like the maximum possible case would be when we delete all the characters. Delete all the A's in the first part. Delete all the B's in the second part. And count is minimum of count comma current. Like this should be order n square algorithm. And like it should be enough to solve the first subtask. Okay, like this copy might not be the way to do it. But yeah, like this process can be optimized, but I will move further. Now let's try to solve it for L2R. Like given substring. Like CIDX is the last place where like character C appears before R. So your loop will look like this. This would be CIDX because you can never delete it. We can brute force on all the possible ways over here. Yes, this is order n cube, and that's the like the code. The way I have written it's n cube, and like that's the reason for the TLE. Like let's say like this is index L, and like this is index R. So like you will have to delete all the B's in this half, all the A's in this half. So like if you take the prefix sum for the complete string, then the number of A you will have to delete is mid minus pref A. Number of B's you will have to delete is and like if you need the minimum value for this for all the possible values. You can notice that only variable here is this mid. This L is fixed for the substring, and this like the last time when C appears is also fixed. So you can move these values out. Like the equation becomes prefix sum of B up to the last time where C appears minus prefix sum of the starting index plus the minimum value in between, which is that would be the difference of pref A minus pref B. Where pref A and pref B are prefix sums for the complete string, not just the substring we are calculating at. And now we can independently calculate sum of all the three parts. We can calculate it uniquely, we can calculate it differently, and then we can use monotonic state to calculate this part. And then we can do this part, like for example, like I will split it into three parts. Like let me pick my in contrast summation first. I first calculated prefix sum of A and B. I simply call them A and B. Like I can also replace, like replacing first character by C should not change anything here. Now for like if my first I am calculating this contribution. So I am maintaining like when was the last C present here. And for all the else less than equal to CIDX, I should add this prefix to the answer. And the possible count here would be like this should be the possible number of B's here. Like this first part as an answer. Now I need minus this, and you can see like it's simply for L. So what I can do is Like the number of possible R for each cell would be this contribution is also done. And now I need this possible part for each possible string, right? So I can look at it as a new value v. Like I can define v mid as ref a mid like 1 second. Now for the third part, like I can define new vector v as ref a mid minus ref b mid. And what I need is essentially the minimum value of v mid for all the possible L to R. And like I would say, like there are many ways to do this. Monotonic stack is one of them. Like you can probably look out over there. The idea is we maintain a stack. We also maintain all the possible values in stack. And like we can maintain like basically how many times a particular number appears. While our stack is not empty, let's look at the top of stack. If top of stack is less than equal to like current value, we do not do anything. Otherwise, we will remove top of stack. And if we take sum of values for all the elements which are in stack over here, like that should be the count of what min value we need at all the places. So like to do that, I can also maintain like an additional value sum stack, which is sum of all the values in the stack. Like remove whatever numbers you have added. Like this was the main idea. Like, am I missing something anywhere? Like, this one looks fine. This one also looks fine to me. No, like, as long as the top of stack is greater than equal to current value, you pop it. Like, this was the main idea. I'm not sure, like, if I'm missing something anywhere. Like, in the first case, it's printing 7. Like, does anyone sees any mistake here? Okay, like, this is in fact fine. Mhm. Like, this is counting the number of bees. Like, in the first part, we should delete the number of A's. Looks fine. Okay, this should be B minus. Now, this is fine. And in the second part, we should delete B, and in the third part, there is no C. Oh, yeah, got it. So, like, basically, like, the value changes only when, like, C changes. One second. This is fine. Why is it minus 3, 4? Second answer, it's printing minus 14. Mhm. To be honest, not really sure what's this. Like, I will leave it for later, but I can say like what I have written in the contest. In the contest, like instead of doing three different for loops, like I had only one for loop for all of them. One was some AI, sum of all the possible AIs, which was directly added to the answer. Like I also had the stack sum with me, and like possible BIs as well. So like I added like current value of A in AI, some AI, and like whenever like current character or C, like I replace like this that with the current answer we had, because the answer only changes when the last character is C. And like the current answer was sum of BR, like the prefix sum into R plus one. Not really sure why I did that. Okay, like these are the possible number of strings that ended at a particular BR. All the possible sum of AI is there, and like all the number of stacks we had. Mhm. So like there might be some mistake here, but like that was the pretty much code I have written. And I will, in the interest of time, I will probably move to the next problem. I think I have shared the ideas for this. Any questions on this one before we move to the next problem? Okay, Seb needs to return some videotapes. A mysterious investment banker has employed Seb to maintain his collection of videotapes. There are n videotapes arranged in a sequential manner from left to right. Seb's job entail performing Q tasks which are told to him by banker in a sequential manner. Given L2R, find the sum of length of all the videotapes which are the leftmost of their particular type. When only sequence of videotapes from L2R are considered. Formally find the sum of all Li across I from L to R such that there does not exist an index here, which is between L and I, such that Cj is equal to Cr. Given x and y, Steph returns the ith videotape, borrows another one with length y and the same type as the returned videotape, and places it at x position from left to right. Formally set Lx equal to y. Given x and y, Steph returns the x videotape, borrows another one with same length as the returned videotape and type y, and replaces it at x position from the left again. Formally set Ci equal to 1. Seth really does not want him to be squared to be the last thing he ever hears. So he must complete every task before banker tells him the next. So the TLDR is like we have some L2R, like we should find the leftmost values for a particular type. And to be honest, like query 2 and query 3 are not different. We can just consider it as updating a particular type over there. Whether it's the first type or second type, it doesn't really matter. Like we can just consider it as changing the value at index I, and then we can try to do whatever we want. So the main idea I had was, let's look at all the values first. Ln Cn. And like let's say like we have some index I, and like how does the cost really matters here? Like let's say like type is 1 2 3 3 2 1 2 3 1 and so on. like let's say we have some CI values here. 1, 2, 4, 3, 4, 5. Not really sure why do I have some latencies. Yeah. So let's say we have these CI values, and let's say we want to find answer for this L2R. I hope this works out. Like I do have some lag. Like, excuse me for a minute. Like not really sure like why today decided to just. Okay, I will try to complete it using mouse only. Okay, looks it's working. Let's say we have some CI values. 1, 2, 4, 2, 1, 3, 4, 1, 5, 1. And let's say we want to find the answer for this. My idea would be like I will take all allies first. I will take sum of all of them. and then I will subtract some of them which are not there for the first time. So for example, I would subtract the cost for this 4 year. I will also subtract the cost for this 1 year because there exists some 4 and 1 before it. So the way to look at this over here is like whenever your right hand, let's call this as index 0, 1, 2, 3, 4, 5, 6, 7. What I will say is like subtract L4 for this index here. If like your right is more than 4. For example, subtract L3 if your R is greater than 3 here. Like basically find the next 4 where it exists and subtract them. Like for example, for this 4, like I would say like subtract this L6 here whenever R is greater than 6 here and so on. So basically what I can say is like I can write sum of L2R here. Like I can take sum of all the lengths here. And then I have some conditions over here. Like subtract some Lj where it can be the case that like for example, I have some arrays, there is 2, then sub 2, then like I'm not really sure like why like whiteboard all of a sudden decided to just ditch me. Yes, sorry for all the issues. Like open more. Okay, right. Okay, looks good. So my idea was like let's say we have some 2's here. Like let's look at the values of C here. Like we have some different values here and there are some 2's like this. I hope there is a free version for Expel which I can use. Like let's say we have some 2's type 2 and there are different types over here. Then my idea was like if this 2 is included, then we should subtract the cost for this one. So basically we have some conditions of form. Like let's call it some index. Let's call it as index 5. Let's call this as index 2. let's call this as index 9 and so on. So now we have conditions. If L is less than equal to 2 and 5 is less than equal to R, then we should subtract like the height of 5 here. Similarly, based on this 5 and 9, we can say like if L is less than equal to 5 and R is less than like 9 is greater than equal to R, then we should also subtract like height of 9. Like instead of height or length, whatever we call and so on, we can say. And like that was the main idea. So like basically I can first take sum of heights from all L to R. And then I can look at updates like this, like based on. There were some ideas to do it. Like the way I did it was using the segment tree. And then I used like at each node of segment tree. Like 2D segment tree was the first idea. So in 2D segment tree, like you have a normal segment tree. And at each node, like you also like at each node, we also maintain a new segment tree. And the problem is like the values in the segment tree can be very large. You can probably use dynamic segment tree. Like that took around log and extra factor, and that gave me a TLE. Like the other option I had was for at each node, I maintained a Fenwick tree, compressed Fenwick tree. And then like I also maintain like some extra nodes over here, like which the values which are not present in that segment tree. The values which are not present in Fenwick tree. And then like rebuilds Fenwick tree. Whenever the extra nodes are greater than some height, let's say 75. That was some parameter I did, and like that was the square root idea we had. And like I will jump on to code for this one. Like sorry for the issues. Like I'm not really sure like why my setup stopped working. First take all the numbers as input. And like decode the query. If it's a first type query, find the answer and print it. Otherwise, like delete the value at index I, update the value at it, and update that value at index again. So the idea was whenever I am adding some index over here, I add that value to Fenwick tree so that I can get range sum over there directly. I try to find one node which is just before it of same type and one node which is just after it of same type. To do that, I can maintain a set for each of the vector types, so that based on the type, like this contains like for every particular index what all values are there. Before I inserted this IDX, like after L, just after L, the next value where the same index was existed was R. So I should remove that link, and like the value before L, before the current index with same type would be L. So I should add a link between them. And I should also add a link between my current index and the value just after it. Here it's of condition of form. Like basically earlier it was saying like you should not count the height at R index if you already have this L value here. Now it says like you should not count the height at index at IDX variable if the left hand side is L. And you should not count value at R if the left hand side also contains this IDX index. Similarly, the delete is similar. Like I find two variables like which are just before and after my current index. And I remove the link from the current index and the value before it. I remove the link between the value just after it and current index, and I add link between L to R here. So it was, and when I'm returning the answer, I take sum from all the values from L to R, and then I also remove those conditional links, sum, subtract, whatever the which I want to here, and return like the remaining part as then. Like for update link, I am using a 2D segment tree, or basically one of them is segment tree and the other is Fenwick tree with some other combination over there. Basically, let's say we have some lazy add variable here. If the link is outside the boundary, remove it. Otherwise, like we should add this value, and like I am a similar segment tree is there. And each if D is one, we should add it, otherwise we should remove it. So at this particular node, it says like so like this was the first part. Like we have some lazy add over here which says at index R add this value over here. And then query sum is like so let's say we have some data structure which contains values from 1 to n. Some of the values are 0 initially and some of them have non-zero values. Whenever we are adding, we says at index R add this current value, at index R remove this value. Like there are some updates at some indexes, and then we have some values which find sum of all the values in the given range from 1 to R. You can look at it kind of a segment tree at each node or a Fenwick tree at each node, and you can see like how does 2D segment tree would work here. And this is my data structure. It maintains a vector v, it maintains a Fenwick tree as well, and then it maintains some extra values as well. There is some rebalance function, like the add function is similar. Find the value in the compressed segment tree which is of equal index. If it exists, add the value in the segment tree. Otherwise, add the value in this extra map we are maintaining. And if value of map exceeds some particular size, let's say 75 IR, then rebalance the same tree so that the extra removes over here, and like you can increase, like basically increase the size of B here. Query is similar. I take like find the smallest index in the segment tree, compress Fenwick tree. I directly take sum of all those values, and then I iterate on the extra map I had, and I count whatever values I wanted and break it over there. Like basically two different data structures are there. And rebalancing part is like I find values for each index. Like I first look at all the values in the segment tree, like this is the value for the segment tree, and like this was the value for this segment tree, like in the Fenwick tree I have. And then I also iterate on the extras data structure. Now A is the one which contains all the values here. So like I sort all the values in the increasing order, and I rebuild my Fenwick tree here of size whatever A has and B dot reserve has, and I push all the values there. And like that was the main idea I had. And I think, and if we look at like all the other aces in the contest as well, like Susil, I'm not really sure what all he did over here, but like I think the idea, there is one segment tree, at each segment tree data is a Fenwick tree, and Fenwick tree uses some GP hash table directly. So like unordered map, and it worked for him. I tried this one with a direct map, and like it did give me a WA. Yeah. Like I'm pretty sure I tried this submission. Some yes, like this is the submission. Like basically in Fenwick we generally maintain an array, but what the first person to AC on this did was maintained an unordered map instead of an array, so that the size of map is small there. Like this was what the first guy did. And like the second guy did something differently. He had some okay, like at least that does not work for my implementation. Second guy had some like 2D Fenwick data structure where he is using some hash map and something like some dynamic segment tree, a generalization of dynamic segment tree we have. And like I'm not sure what the third person did, but yeah, pretty much that was the idea. So any questions on this one or any other questions related to anything before we call it a day today? Like it's quite a long today. And like not really sure like why my writing pad decided to just give up today. Okay, I am in my fourth year, 3-star in CodeChef people on code forces. What should I continue? CP or start development? So like first question, like do you like will you graduate in like next 3-4 months or like will you graduate just after a year? Like honestly, like for me, like it's a bit tricky questions, like because like I generally try to avoid saying either do CP or dev. Like my suggestion mostly lies on try both of them. Or like the last time, like I answered was okay next 2 months. Like to be honest, I would say like if we haven't done any development, then like get started with it, and like that would be a bit critical because like there are interviews which are apart from CPs over there. And like for like you might want to do lead code, and like I would say like the best time spent over here would be on lead code I would say, rather than like code forces, because the way I see lead code contest is like these are the problems you might get in an interview tomorrow. But for CodeChef and code forces, like it's maybe a really an overkill. Like you may get better result doing lead code compared to CodeChef and code forces, because like if you probably solve a problem on lead code contest, there is a good chance that it would be asked in an interview tomorrow, compared to like a code forces problem A or problem B, like relative probability if you ask me, to be honest. So like you can probably start with lead code problems. Like there are top 75 lead code problem. There is some Striver A to Z DSS seat is there, and like there is some lead code 75 over there. Like those are the problems you should try, and like you should definitely start some development activities there, like at least some side project or something which gives you something to talk about in the interview. Lead code contest seems much easier nowadays somehow. Like I'm not really sure how much you will consider nowadays. Like I think the last contest I participated was like on March 24. Like so I think I participated a month ago. And like it was a bit of random there. Like sometimes the code problem was too hard and sometimes it was kept solvable by around 800 1000 people. And to be honest, I do not have idea of what companies ask in OA because like the last interview I gave was 3 4 years ago. So like I may not be a good person to answer right now. And like basically my general advice has been like if you are looking for some intern placement in next 6 months or 9 months, you may get better results solving problems on lead code rather than trying to solve on code forces or CodeChef. And like some side project is always a plus there. And like you might also want to optimize on which companies you are targeting. Some of them solely ask on DSA problems. Some of them like do prefer asking some development or assignment. Like the best way would be like have some target companies. Look at lead code, Glassdoor to have some interview experiences of people what companies do ask on wherever you are applying, and then you can try to optimize based on that. So like any more questions there? Okay, probably it's around 2 hours right now, and like I'm not really sure how good I was able to explain the last problem, but I hope other problems were at least explainable. And like I will probably end the stream if there are no further questions. So that I will get time to brush up my skill. Thank you for this. Yeah. Yeah, like thanks everyone for joining. Like basically I'm not at my regular place right now, so like I do get some internet connectivity issues in between.